Good morning, all. For sound check, can someone please unmute and let me know if you can hear me?
Good morning, boss. We can hear you, sir.
Thank you very much, Thank you very much, Dr. Schreiber. I appreciate that.
Thank you, sir.
Okay. I welcome you all to this class. And please, I don't know, those of you writing names here, please don't, you're disturbing the class. Dr. Schreiber, what can we do about these people that are sending their names?
To do that just to show that they are present in class.
Yeah, there's no way we can mute it, right?
Except you go back, we can go back to setting and just mute it completely. That's hide the profile. Otherwise, just allow it. You can leave it. That's the way
you can see.
Just to show that.
You can see this one now has written a whole. It's disturbing the class. I can't see this screen with all this their stuff.
Just go back to your own slide and continue. I will see if it's possible to mute it. You are live on YouTube as well, sir.
Thank you very much. I feel like a rock star already.
Thank you, sir.
Yeah, let me just try that security. Say hide all profile pictures. Okay, let's see whether that will do the job. Okay, I welcome you all to this class. Over the last couple of weeks, that didn't work. Over the last couple of weeks, you have gone through various topics.
You can continue, sir. I've just observed that you didn't do all the settings that I asked you to do. Just go ahead. I will do the settings, sir. Continue, sir.
Whatever you need to do to stop this stuff, go ahead.
Thank you, sir.
So we're going to be talking about electrochemistry. This part of the course is where we discuss the relationship between electricity and chemistry. As I'm sure you are aware, everything about life is basically chemistry. There's nothing that you can talk about in life that you won't be able to relate to chemistry. And chemistry is motivated by electrons, the movement of electrons. So if you're getting any kind of reaction, it usually involves the movement of electrons, usually from one point to the other. So when you talk about electrochemistry, you're talking about the study of how chemical energy is converted to electrical energy and vice versa. Okay, we would have learned in secondary school that matter can neither be created nor destroyed, and therefore we have conservation of energy. So when you therefore talk about electrochemistry, it boils down to oxidation and reduction reactions. These are two reactions that occur concurrently or simultaneously. That's to say, oxidation cannot occur without reduction, and reduction cannot occur without oxidation. So when these reactions occur concurrently, usually would have energy being produced. So the reactions are brought about by interaction of chemicals or atoms, the electrons of atoms, and they would therefore usually produce energy, as well as producing products, as I'm sure you're all aware. So it's this energy, its generation and its use that we're going to be dealing with when we talk about electrochemistry. So quickly, let's remind ourselves of salient definitions or terms that would have come across. Everybody in this class did JAM. Even those are by, so if you're here, you would have at least done a bit of chemistry. So First bullet point, oxidation and reduction occur simultaneously. That means together. One cannot go without the other. It's like eba and soup. So I know some people eat eba without soup. So what is oxidation? Oxidation can be defined in different ways, just like reduction can be defined in different ways. One of the definitions is in terms of electrons. Electron loss or electron gain. So oxidation is the process of electron loss. Reduction is the process of electron gain. So if you were to, for instance, look at this and say you have an element, okay? If you say plus E, it will give you E minus, for example, okay? So in this case, E has gained electron. So E has undergone a reduction process. But if in the otherwise you have if in the other way is my eraser, that's my eraser. Okay, simplistically now, if you have E minus E, it will give you E plus. Okay, so simplistically, you have that E has lost electrons. So that process of E moving from E to E plus is what you would call oxidation. Okay, so that's in terms of electrons, loss or gain. You can also define them in terms of oxidation numbers. So oxidation will be an increase in oxidation number. Reduction will be a decrease in oxidation number. So again, you look, oxidation number, if it's a number, if it's increasing, then it's oxidation. If it's decreasing, it's reduction. That one is very easy to remember. Something is decreasing, is reducing. So if oxidation number is decreasing, it's a reduction. These are things you've heard before, but this is just to help you remember, because you have to have these definitions at the tip of your fingers to be able to do well in this part of the course. So what is an oxidizing agent? An oxidizing agent is the agent that accepts the electrons that the reducing agent produces or donates. Again, you notice that oxidation is the opposite of reduction because they happen at the same time. When one is going up, the other one is coming down. Okay? So try not to confuse oxidizing agent with oxidation. Okay? So you have to take note of that. That's why, for instance, they say make sure you understand the question before you give an answer. Oxidizing agent is different from oxidation. Oxidizing agent is the species. Oxidizing or reducing agent is the species, the atom, the moiety that undergoes oxidation or reduction. While oxidation or reduction is a process. Okay, so an oxidizing agent will be reduced in the reaction while a reducing agent will be oxidized. You can come back to those definitions later, just to be sure you know. No, that's not what I meant to do. What's going on? Okay, this does not want to. I think I've lost that connection. Bear with me a while. Okay, there we go. So what What is that plus doing there? Okay. We'll leave that and move on. So let's look at some reactions. Suffice it to know that a redox reaction is a reaction in which you have a reduction and oxidation. So that reaction is usually called a redox reaction. And a redox reaction is made up of a reduction and oxidation. You can see how that has been combined there. So a reduction will go through a set of equations and is described as half reaction. And then oxidation will have its own equation. It's called also half reaction. So a redox reaction is the sum of the two half reactions. In a reduction half reaction, you can see that electrons are gained. Cast your mind back to the definitions we outlined at the beginning. We said that reduction is electron gain. Okay? And like the example I gave you with E, this is a typical example now of here you have hydrogen H plus, aqueous, the AQ there is aqueous. So that means that that entity you're seeing there is dissolved in water. So in water, it has ionized to H plus. Now you see plus 2E minus. So first of all, if we're doing this, you're going to have the H plus, don't mind the handwriting, plus E. Let's take that. Let's do that again. This plus is looking very strange. Okay. So H plus, we know that that's a proton in solution. Let's say plus E. This is E is an electron. It just is by convention is written as E minus to show that it's an electron and is negatively charged. Okay, so it gives hydrogen. The G in bracket is gas. Okay, AQ is aqueous in solution. Now, if one H plus gains one electron, okay, let's do that step by step. H plus, like we did before, it gains one electron, is going to give you H. Okay, so the electron will go and occupy the empty orbital. So if you were writing this H, we have, I'm sure you are aware, hydrogen has just one electron. So H plus means there's no electron. It just has neutrons and protons. Or rather, yeah, neutron and proton, I meant to say. So if it gains one electron, it will form H. Okay? Then this H will react with another H to form H2, which is the gas, which is what you're seeing here. Okay? Now, if you now mean that means that this H, two of it, has to react with two or gain two electrons in order to give you H2. And that is what you have here. And from the equation, you can see that 2H plus has gained two electrons to give you hydrogen gas. That process is an electron gain. If you move down to the next one, you will see that Zn is zinc. S in the bracket means it's solid. Okay. Now that zinc, being a metal, can give out electrons. So it's electropositive. Okay. And is a transition metal that can give out two electrons. When it gives out two electrons, you know that a neutral atom, the protons, number of protons is equal to number of electrons. So, but when you remove the electron, the proton will still be there. And that's where you now have the excess positive charge. So that if you take zinc, you remove 2 electrons from it, it will now have, before here, it's not written, but here is 0. Don't mind the way I wrote 0. But if you are writing, instead of, if you were going to write the oxidation state here, it would have been 0 there. Okay? So 0 because the positive of the protons neutralizes the negative of the electron. But when you now take away 2 electrons, take away 1 electron, it will be Z plus. You take away 2, it will be Zn2 plus. Okay? Now, ordinarily, you can write this. Let me clean all this off. Okay. So ordinarily, this you can write as Zn, because it's losing electrons, you can say minus E minus. We give you Zn plus. Just like we did when we're talking about gain. But here is loss. Okay? But you see, the convention is you now move this way. I'm sure from secondary school you can remember that when you move negative across the equal to sign or the arrow, it becomes positive. That's why you have this positive, and on this side, what you call the right hand side. Okay? Now, zinc will not exhibit an oxidation state of 1. As you go higher, if you learn more chemistry, you understand why this is so. But I'm sure in secondary school you were taught sp and d orbitals, and zinc, being a transition metal, has empty d orbitals to which it can accept electron. Okay, and it is more comfortable accepting the 2 because of the 3s and 3d. You will learn all that in the future, but it suffices here to say that you're going to be having Zn2 plus and not just Zn plus. If it's 2, then obviously the equation has to balance. And that's why, oh no, you don't have 2 here. It's the electrons that have to balance. Zn, okay? So this 2e minus 2e, instead of writing it minus 2e, the convention is to move it to the other side. It now becomes plus 2e. Okay? So if it's confusing you whether it is an electron gain or electron loss, just do simple maths. If it's electron gain, it's plus. If it's electron loss, is minus. And then once you have minus, because the convention is that you now move it so that it will always be plus. Okay? Now, another reason why you do that is to balance the charges. You move it to this side, you find out that 2 plus 2e minus will be 0, Zn 0. I hope that is self-explanatory. Any questions? If you have any questions, please click the raise hand button and we'll attend to you. So intermittently, we'll break to answer questions. So if I'm talking and there's something you don't understand, just write it down. So if you write it down, and then when I ask for questions, you can raise up your hand. Abdul, back at Adeyemi, unmute yourself and ask your question. I see 2 already. Adeyemi. Okay, I think I have to unmute you. If you, let me see. Where's the Adeyemi? Adeyemi, unmute yourself.
Good morning, sir.
Yes, quick.
Yes, sir.
What's the
So
question?
is the to get the oxidation number a prerequisite for us to know whether the amount of electron gain or electron loss? Like, do we have to know the oxidation number for us to get the electron gain or electron loss?
I think yes, you have to.
Okay, sir.
Because
Thank you.
again, you have to remember that some elements can have variable oxidation states. Okay, that means
Yes.
that sometimes they can lose one electron, sometimes they can gain one electron, sometimes they can also gain two or lose two. So usually it will show, but generally speaking, you don't have loss or gain of more than 1 to 2 electrons, and I'm sure you understand why that is so. You have groups 1 to 2, 1 to 3. Even the 3 is rare, so it's usually 1 or 2, and you find out that these are common with the alkaline earth metals or metals generally, groups 1 to 3, and then obviously the transition metals. So the answer to your question is yes.
Thanks, sir.
Someone else has their hand up. Promise. Okay, what promise?
No, sir.
Okay, ask your question now. We already know it's good morning.
So can you please come again and explain why you shifted the ZN2
Don't
plus to the
tell me
left-hand
to
side?
come again. Don't ever tell me to come again. Ask your question.
I'm sorry, sir. Can you explain why you shifted the ZN2 plus to the left-hand side?
It's the convention.
Okay, sir.
We write it as plus 2e. It's convention. I was only giving you that example to help you remember it. If you're coming across it for the first time and it's confusing you, loss is minus, gain is plus. If you look at the metal or the element that is losing, if you put minus in front of it, then on the other side, you put what is giving you. But when you are going to write, that's in your head, that's how you're going to do it. But when you are going to write it down, you write it in such a way that the charges are always on one side, the non-charges are on one side. So if you look at the first equation here, the charges, one on the H and one on the E, they are both on one side. In this case, they are on the left-hand side. Then if you look at the oxidation, the charges are on the right-hand side. Okay. So moving on, go to the next slide. We say that the reduced and oxidized species in a half reaction form a redox couple. I'm sure we all know what a couple is. And we usually would denote it by ox/red. That is very important. All X is oxidation. You have that slash, and then you have red, which is reduction. So if you look at, we'll go back again, look at this equation that we've written here. The first one is a reduction half reaction. Second one is the oxidation half reaction. Now, if you want to write them in shorthand, you can see that, first of all, the first one is the oxidation. Hold on. That's another thing you have to take note of so that you don't get confused. You see, this 2H plus plus E to give you hydrogen, that is the reduction half reaction. Okay? The whole reaction as a whole is a reduction because there's electron gain. But the species themselves, one has been reduced, one has been oxidized, even within that reaction itself. Okay? So if you look at it now, if you look at each of them, individually. Look at H plus and then look at H2 plus. In moving from H plus to H2, the H has gained electron, and that is why it is a reduction reaction. Okay, but now if you look at the redox couple, that means that what are the things that are involved? You will also notice, for instance, that this 2H plus plus 2E, if you reverse the reaction, you are going to get an oxidation reaction. In other words, if you take this H2 and you put minus 2E minus, I'm using this to try and explain the next slide so that you don't get confused. If, say, for instance, this reaction now, if you reverse it, if it goes this way, that you now have H2 gas minus 2E minus, you will see that it will also give you 2H plus. Okay, so if you are moving in the opposite direction now, you will notice that H here was or had an oxidation number of 0, but in moving here now, it now has an oxidation number of +1. That's moved from 0 to +1. That is an increase. Okay, but if you look the way we've written it, the H plus has lost an electron. But again, remember, we don't write it like this. We move this here, so that it will now be, if you were reversing this, to still be this, just that the arrow has changed. So it's a loss of electron, and so you can describe that backward reaction as an oxidation. Hence, if you are talking about a redox couple, this keeps moving. We are talking about a redox couple. Where are we? Here. That's how come you have that it will be H plus slash H2 or Z2 plus slash Zn. Now this brings to 4 what I warned us about here. I said here you have to be able to differentiate between the process and the entities involved in the process. You have to be able to distinguish between an oxidation and an oxidizing agent. And then you have to remember that an oxidizing agent is reduced while a reducing agent is oxidized. So it's always the opposite happening. Okay, so if you come here, when you talk about a redox couple, the reduced species is the oxidizing agent. The oxidized species is the reducing agent. So please take note of that. You can go over it later just to get, you don't try and understand them now so that you don't get them confused. So the oxidized species, the H plus slash the reduced species, RED, H2. So that's how you write it, the shorthand. Or, so these two that you have here are these equations that we had here. Okay, but then notice that the equation as a whole is a reduction half reaction because electrons are gained. Okay, and I said if you can flip the reaction the other way, if you reverse it, you find out that it's the opposite. That is that the hydrogen gas will lose electrons in order to form the hydrogen ion or the proton or the hydrogen cation, whichever one you wish to use. Same applies for the Zn2 plus and Zn. Okay, so that is the couple is written with the oxidized species before the reduced species. H plus and Zn2 plus are oxidized, whereas H2 and Zn are reduced. Again, please look at that so that you get them and you do not confuse them. Now let's look at an example. Many of you would have come across zinc sulfate, copper sulfate. Use this for even experiments when you do electrolysis in secondary school. For those of you who went that far. Okay, so want to look at the reaction of zinc with copper sulfate solution, or if you copper 2 sulfate. You want to say the, so if you look at the equation down here, zinc is solid, copper 2 sulfate is aqueous, that means it's in solution. So that equation will give you zinc sulfate and copper 2 sulfate. Now, those of you who have seen this reaction, you will know that copper 2 sulfate is deep blue. And when you throw the zinc metal into it, you gradually will observe it become lighter. And then you look at the bottom, you will see something brownish. Or you look around the electrode that you put around the zinc you put, you find out is disappearing, and then you're getting another color. Okay, now that equation, we can break it down. The first reaction there is the full reaction. The next one are the half reactions. Okay, you see that you can break this down. If you take the first oxidation half reaction, you have the zinc solid. It's going to lose 2 electrons to give you the zinc 2 plus. Okay, so electron loss is oxidation, or increase in oxidation number is oxidation. So those are the 2 ways you can look at that. And we're not mentioning it here, but you would have learned in secondary school that oxidation is the addition of oxygen or the removal of hydrogen. That's also a tenable definition, except that it's not necessarily applicable here. Okay, so we are focusing on the other definitions in terms of oxidation number and electron loss or gain, in order for us to understand what we're talking about. Okay, so again, if you take here, I'm sure you know this. No, that's not what we want. Yep. This, you can break it up to C2 plus SO4 2 minus. Okay, so in a manner of speaking, this is the same thing as this. So that if it comes here now, the Cu plus is what comes here. And you can see that it's gaining 2 electrons to give you the copper. Now, if you look carefully, you will note that when this loses 2 electrons, this picks up the 2 electrons. Okay, that's basically how it works, because the oxidation and the reaction go together. So if you break that up, you will see. So you look at, that's why they have reactions. So this second one, copper 2 plus 2 E minus, that tells you that the copper 2 plus is gaining 2 electrons in order to give you the copper solid. The copper 2 plus is in aqueous solution. You can see it here. That's what has been broken down here. You will notice that the SO4 has not been shown in this reaction. Okay, that's basically because we are concentrating on the metals. because it's the metals that are gaining and losing electrons. The SO4 maintains here, SO4 is 2 minus, here SO4 is 2 minus. So that is constant. So that's why we're not bothering about it. Okay? But here, Z is 0, Cu is 2 plus, here Z is 2 plus, Cu is 0. You can see those are the ones changing. And you can, if you come to the half reactions, you see them. And then usually half reactions, half and half make 1. So you find out that you can easily add them up. So if you come here now, you say, if this plus 2E cancels this plus 2E, you're now going to have on this side Zn solid plus this. Then you have the arrow, and on the other side, you have Z2 plus copper. Okay? So you are adding them together. This, in a manner of speaking, this plus this. So because this, and if that confuses you, and you want to do basic maths, you can say, you can say, for instance, that this plus, if you move it to this side, becomes plus 2E minus. Sorry, minus. If you move plus across the equal to sign, it becomes minus. So instead of it being C2 plus 2E minus to give you Cu, if you move this plus 2E minus to this side, it becomes minus 2E minus. Okay, so you can then say plus 2E minus plus minus 2E minus will give you 0. And that's why this cancels this. And then you have this equation. Questions? Any questions on that? Well, they are there. You can always look at them. And no, that's not what I wanted to do. Okay, we'll move to the next slide. No, Guinea Victor, you have to wait till the next round of questions come around. Put down your hand, wait. I'll give you opportunity next time. Okay. On this slide, we have, I'm sure many of you know what mnemonics are. There are simple ways that words that we use to remember complex things. Those are what you call mnemonics. Some people put P in front of the M. Anyway, so look at this. Oil rig is a very good way to remember what oxidation and reduction is. Oil is oxidation, is loss of electron. Rig is reduction, is gain of electron. If it's confusing you and you need to remember oil rig. That will tell you that oxidation is loss, reduction is gain. Remember at the beginning we said they occur simultaneously, so one cannot occur without the other. Okay, what was his name? Victor. Victor, you can raise your hand now. Let me go and find you. We can take questions before we move to electrolysis. Okay, what's your question? Victor, please unmute yourself and ask your question.
Okay, sir. Sir, you said for that copper 2 sulfate and zinc sulfate, you said we are not going to be concerned on the sulfate radical there. Why?
You heard that, but you didn't hear the reason.
No, sir.
because the charges are constant.
Okay, sir.
So there's no change. We're looking at where you have change. I'll go
Okay,
back
sir.
there.
Okay, sir.
We're looking at where you have change. We said that here, we've already broken it up, that this SO4, what's this? The SO4 is 2 minus here on this side. On this side is also 2 minus.
Okay, sir.
So it's constant.
Okay,
You can put them if you want.
okay, sir.
But what we're just trying to do is to show the reactions using ionic notations.
Okay, sir.
So here, for instance, Kehinde, you are blocking our view. Oya, ask your question. Aregbeshola, unmute yourself
Yes, sir.
and ask.
Okay, sir. I wanted to ask, naturally, metal. Yeah. I wanted to ask, naturally, metals are reducing in nature. Does the position of metals in the electrochemical series determine, okay, which one behaves as oxidizing? For instance, this zinc and copper. Zinc is higher than copper naturally in the electrochemical series, and as a result, does it matter if like the position in the electrochemical series, or they can actually be altered? It doesn't really depends on their position in electrochemical series to determine which one.
You are
Okay,
breaking
this
up.
one is oxidizing
You are
in nature
breaking
or
up,
reducing.
Aregbeshola. The question you're asking is futuristic. We're still going to deal with it in the future. But since you've asked, the simple answer to your question is yes. It determines the position in the electrochemical series determines. We're going to deal with the electrochemical series way ahead after we've talked about electrolysis. So let's not jump the gun so that we don't confuse ourselves. But the answer to your question is yes, and we will deal with it in the future when we talk about electrochemical series. Okay? Any other question? No other question. So we move to electrolysis. Again, this is something you would have talked about in secondary school, so it is not totally new. Electrolysis is the composition of a compound. The compound has to be in solution or molten. Molten, maybe at this stage, let's describe it as jelly-like. You know, you can compare your tea to your ogi or your akamu or your pap. If you, many of you might not know how to make it so, but you look at ogi is like a gel. That's how best you can describe what you say is molten. You know that it's somewhere between a molten is somewhere between a liquid and a solid. Solid, the constituting bodies in a solid are immobile. Okay, they are held in a particular structure. They have a definite structure, chemical lattice and all that. But a liquid, it's more mobile. Okay, it can fill a vessel and all that. You would have learned all that in secondary school. So molten is somewhere in between. Is somewhere between being very mobile and not being mobile at all. Okay, so a compound has to be in the molten state or in solution before it can undergo electrolysis. And when that compound is in that state, in the process of decomposing, it will give out electricity or electric current. So there's how you come about the conversion of chemical energy to electrical energy. Okay, so electrolysis will be the process. So it's decomposition, simply put, is the composition of a compound by passing an electric current. In this case now, you are taking the electric current, which is electrical energy, and you are converting it into chemical energy, because you take the electrical energy, you inject it into the chemical, and then there is a decomposition, which is a chemical reaction. So here, chemical energy is being converted, electrical energy is being converted to chemical energy. Okay, so bullet point 2 puts it simply by saying that electrical energy is used to produce chemical change. Now, reduction occurs at the cathode, while oxidation occurs at the anode. Cathode and anodes are the electrodes. I think in the next slide we'll see another definition. Okay, cations and anions, I'm sure you already know. Cations are positive ions, anions are negative ions. You learned that in secondary school. You would have also learned that the cations will migrate to the cathode and the anions will migrate to the anode. In electrolysis, we'll soon find out why that in electrolysis caveat is very important. But at this point, let's note that cations, which are positive ions, will always go to the cathode, which is a negative electrode. And because positive attract negative, the positive ions will go to the negative electrode. But I think the next slide defines this. Okay. There you go. So, electrode. What is an electrode? Can be a metal, can be a strip, can be a wire. Some of you will see, you take, those of you who are good in the electricals, you take a wire, you connect one end to the other, you can short circuit it, or you take a wire, connect one end to a battery, connect one end to a light bulb. You see that the light comes on. The energy in the battery passes through the wire and goes to light the bulb. So the energy in the battery is chemical energy. We're going to deal with all that later. But here, we want to take note of important definitions. That is the electrode. We said that the anode is the negative electrode where oxidation occurs. The cathode is the positive electrode where reduction occurs. Now, look at this and come back to this. Here, the cathode, so you have to take note of that. In electrolysis, the cathode is the negative, the anode is the positive. In electrochemical cells, the opposite occurs. And in the cell, you would have that the electrons will flow from the anode, which is the negative electrode, to the cathode. So please, at your own time, revise these two slides and take note of the differences because they can be confusing. Again, when you see the diagram, so this last bullet point here, the anode is placed on the left by convention, as diagrammatically. Okay, more definitions. An electrolyte is a solution or molten that can conduct electric currents. A salt bridge connects the electrolytes. Again, we're talking about electrochemical cells now. Okay. You must be able to differentiate the process of electrolysis to electrochemical cells. They are opposite. In electrolysis, you are applying electrical energy and you are getting a chemical change. In other words, you're changing electrical energy to chemical energy. In electrochemical cells, you have the chemical energy in the cells and you're converting it to electrical energy by the reaction at the electrodes. The interaction of the electrodes with the electrolyte and the salt bridge that divides the electrolyte so that they don't mix. So please, again, it's something you will have to look at. I will take questions on this in the next class, by which time you'd have had time to look at them so that don't get confused. 1 minute, the anode is the positive electrode, the next minute, the anode is the negative electrode. It's because they are different when you talk about the electrolysis and when you talk about electrochemical cells. In one case, chemical energy is being converted to electrical energy. In the other case, electrical energy is being converted to chemical energy. So they are opposite. Just like you have oxidation and reduction being opposites. Okay? So look at those, look at the definitions, and then you should be fine. Here, we're talking about the salt bridge. You will see it in the diagram. It connects the electrolyte, okay, ensuring that there's electrical contact. Just like the example I gave, the wire will ensure that there's a contact between your battery and your bulb before you can have the bulb coming on. Okay, it is made up of a gel permeated with the solution of an inert electrolyte. Okay, so the salt bridge is supposed to be inert. It should not partake in the reaction that is going on in the electrolyte. You will see why as we move forward. Okay, the electrolytes themselves should also not mix. Okay, if they do, then they will overcrowd. There's a word for it. We're going to learn that as we move ahead. So in other words, the salt bridge has to be electrically neutral of the half cells as the electrons or ions flow. Now, this is a diagram of an electrical or electrochemical cell. Okay. Now, if you look carefully, you will see where you have the KNO3, that's the salt bridge. You see, the salt bridge should be able to conduct ions up. It should be polar, it should be able to allow ions move through it, but it should be neutral. In other words, it should not participate. Now, if you look at the beakers on the sides, you see that they are not together. So in one beaker, you have zinc nitrate. In the other beaker, you have copper nitrate. Those are the electrolytes, and they are not mixing. Okay? And then you have bars there. See, one is a zinc electrode, the other one is a copper electrode. Okay? And then you see that the electrodes are connected. The voltmeter is used to measure electric current. Okay? So this is an example of an electrochemical cell. And then you can see the chemistry there. The zinc here, we lose 2 electrons to form zinc 2 plus. Again, see how the equation has been written. Zinc is the one losing electrons, but the electron has been moved across. So now it's now zinc 2 plus plus. So it looks like it's the zinc that is gaining electrons. Okay? And this is the anode. Okay? Because here is where the oxidation is happening. You can see that there is increase in oxidation number from 0 to +2. So that's oxidation. But if you look at the other beaker that has the other electrolyte, the zinc nitrate, you can see that the copper nitrate, you can see that the copper ion, that's Cu2 plus, gains 2 electrons to form the copper solid. There is therefore a decrease in oxidation number from copper 2 plus to copper solid, and that's why it's a reduction. You can also say there's a gain of electrons Again, you cast your mind to rig, oil rig, oxidation is electron loss. Reduction is electron gain. You can see that that is totally taking effect here. Okay? So you might wonder, where is this zinc solid coming from? The zinc solid is coming from this zinc nitrate enabled by the zinc electrode. And then the charge, which is the 2 electrons, is able to pass through the potassium nitrate bridge, KNO3, and then come here. So that in the beaker by your left, you have electron being given out, and in the beaker to your right, you have electron being received. And that is how you form. Now, from this reaction going on, you find out that it will generate an electric current, which the voltmeter will measure. So you have the conversion of chemical energy from the beaker to electrical energy measured by the voltmeter. And if you look at it critically, you see that usually is movement of electrons. So you have that electrons will usually move from negative to positive. So if you look at this diagram, if you were to draw, you see that electrons are moving in the beaker from the left beaker to the right beaker. Okay? And that's the internal circuit, if you like. But in the external circuit, you have that electrons are moving from the copper electrode to the zinc electrode. Okay? And then if you look at the voltmeter, you see that the part that is the positively charged is the one that is on your right-hand side, where the electrons are going to come from. So in a manner of speaking, in the internal circuit, electrons will move from where you have electron loss to where you have electron gain. In the external circuit, electrons will move from the positive to the negative. Again, that is something you have to take note of in terms of movement of electrons or movement of current. Any questions? Okay, so please go over these slides. We'll start on Wednesday by taking questions on this. It can be a bit confusing, so please do not leave it. Go over it and make sure you sort out the confusion in your head. Do not wait till exam to sort out the confusion. It will be futile to do that. Thank you very much. See you on Wednesday. Enjoy your day.
12 to 1. Thank you, sir. 12 to 1, students. See you on Wednesday.